So good morning to all of you. Today we are going to discuss about the topic design of spur gear. The term gear means tooth repeat. It is used for power transmission. So transfer the power from one shaft to other shaft. Here spur gear. So spur gear, it is the simplest form of gear. So it is the simplest form of gear. Each tooth in the gears are aligned parallel to the axis of the gear. So these gears are meshed together correctly. Only these gears are arranged in the parallel shafts. These gears are excellent at moderate speed. That means at medium speed it can transfer the maximum power. So at higher speed there is a lot of noise produced in the gear transmission system. These gears are classified into two types: external gear, internal gear. In external gear, gear teeth are formed on outer surface of the blank, and internal gear teeth are formed on inner surface of the plank. See here, this is the image of the external spur gear. So spur gear, it is the simplest form of gear. Each tooth on the gear is aligned parallel to the axis of the gear. So here gear axis and the same, the gear tooth is parallel to the gear axis. So external gear, teeth formed on outer surface of the plank. In internal gear, teeth formed on inner surface of the plank. So this arrangement, so gear pair. The larger gear is the gear, smallest gear is the pinion. So power transfer from pinion to gear. Advantages of the spur gear system. It has the high power transmission efficiency. The next advantage is it is easy to install. The next one is the constant velocity ratio. The speed ratio between the pinion gear to gear. And in this gear transfer system there is no slip. That means no loss of power. Spur gears are highly reliable. The disadvantages here are it has limited center distance. The power transfer is within the very short distance. It can transfer the power for very small center distance. The distance between the two parallel shafts is minimum. Spur gear produces a lot of noise at higher speed. So gear teeth experience a large amount of stresses. So engagement, there is the complete engagement between the meshing gear. So the lot of stresses act on the each tooth. Here we are going to see the design procedure. First, selection of material. In every problem, they mentioned material of the gear and pinion. Suppose if they didn't mention any material in the problem, we have to choose the material for pinion and gear. From the assumption basis, we are going to see use the PSG data book. From the PSG data book, we can choose the material for pinion and material for gear. The two materials may be same or different. So here the first step is to select the suitable material for pinion and gear. The selection is based on power transmission value. So how much amount of power transferred from one shaft to another shaft. We take the data and find the material for pinion and gear using the power transmission value. So next step is calculation of Z1 and Z2. So Z1 means number of tooth in pinion. Z2 means number of tooth in gear. So in many problems they mentioned number of gear in pinion and number of tooth in gear. If suppose not mentioned, we initially assume the number of teeth in the pinion is greater than 7. So we assume the number of teeth of the pinion, the assumed value must be greater than 7. Then next we are going to find the number of the number of teeth on gear. We using the speed ratio or gear ratio. To use the gear ratio, we can calculate the number of teeth on the gear from gear ratio on number of teeth on pinion. The third step is calculation of tangential load act on the tooth. This tangential load, is the very useful load for power transmission. So we are going to calculate the tangential load. So tangential load equal to Ft. So from the relation, we form the formula Ft equal to P by V times K naught. P, power transmission value. V, linear velocity. K, surface factor or shock factor. In the problem, we calculate they given the power ratio, power transmission value, and the pitch line velocity we can calculate from the V equal to pi d divided by 60. D is the pitch circle diameter, N is the RPM. The D calculated from the gear ratio. So gear ratio formulas we can calculate from the formula we can calculate the D, pitch circle diameter of the pinion. So substitute the value, power transmission value in watt and velocity in meter per second, K naught, service factor or shock factor. We can take the value from the PhD data book based on power transmission value. The next step is calculation of initial dynamic load. The dynamic load formula Fd equal to Ft by Cv. Here Ft is the tangential load. In previous step we calculated the Ft value. Here Cv. Cv is the velocity factor. We take the Cv value from the PhD design data book based on velocity of the pinion. Okay, we have the data V, we have the pitch line velocity. From this value we can take the data for Cv, velocity factor, and substitute this value and calculate the dynamic load. Next, calculation of beam strength. Here the term comes the beam. In gear theory, we consider each tooth as the cantilever beam. So each tooth as the cantilever beam. Each tooth carry the maximum load. So we assume teeth as the cantilever beam. So we are going to calculate the strength of the beam or strength of each tooth on the spur gear. Here the formula Fs equal to pi times m b y sigma b. Here m is the module of the gear, b is the phase width, y is the form factor value, Lewis form factor value, sigma b is the bending stress, designed bending stress. So in this problem, up to this step, we have select the material, calculate the number of teeth on each gear and pinion. Next we calculate the tangential load, dynamic load and beam strength. Next in the calculation of module. Next we are going to calculate the module value. So gear design is based on the gear is designed on the basis of beam strength. So we calculate the value beam strength equal to dynamic load. We equate the previous two formulas. Fs equal to Fd. Fs beam strength, Fd dynamic load value. Equate these above two equation and can calculate the module value. From this module value, using the value we calculate the phase width, d1 pitch circle diameter, pinion pitch circle diameter, b pitch line velocity. We initially assume b equal to phase width equal to 10 times the module. The module value is we calculated from Fs equal to Fe. We equate the two equation and find the module value. From this module value we can calculate the phase width. We assume the phase width B equal to 10 times the module and substitute the module value, we find the B. And pitch circle diameter we calculate from the gear ratio value. So find the pitch line velocity. Next, recalculation of beam strength. That means in previous step we assume module equal to 10. So in previous step we calculate the two, equate the two equation and find the value and substitute the module value M, B, Y, sigma B. So we calculate the Fs value. Then calculation of accurate dynamic loading. So accurate dynamic loading value, we have the formula Ft plus F1. The value B and C constant value. These constant values are taken from the PSG data book based on the gear life and gear material, the error in the answers. The last step is check for beam strength. So we calculated the dynamic load value and Fs beam strength value. If the dynamic load value is less than strength of the beam, the design is safe. Suppose if the Fd value is greater than Fs, the design is not safe. Suppose our answer is design is not safe, we again go to the step. Here. Again go to the step and assume the another module value and find the Fd and Fs value and compare the answers. The last step is calculation of basic dimensions of the pinion and gear. Suppose the design is safe, next we calculate the basic dimensions of the pinion and gear. So module value 2A. So A is the center distance. Z1 number of tooth on pinion, number of tooth on gear, Z2. So we are going to calculate the center distance, height factor, bottom clearance. Bottom clearance equal to 0.25 m. M is the module. Tooth depth, height equal to 2.25 m. So for 2.25 m, m means the module. Pitch circle diameter, tip diameter, root diameter. Okay. So this is the design procedure for spur gear. Thank you.